Electronic paper displays have been a gift to avid readers. It's a type of digital display that resembles ink and paper, even though the individual pixels rely on transistors. They have low power consumption and daylight readability that conventional LCDs simply can't match. Today, we'll explore how to use one of them. Welcome to Unboxing Tomorrow, where we discuss electronics, robotics, IoT, and communication systems. Before I get started today, I should note that this walkthrough is part of a paid promotion sponsored by Crystalfontz America. Crystalfontz was kind enough to supply this display for examination, as well as the adapter board. And with that, we'll do things in our normal format, viewing the initial product, demonstrating step by step how I got my own e-paper display working, how to upload your own custom images, such as this QR code, and finally, just a few things to keep in mind while you're using the equipment. As a side note, I've been using Crystalfontz technology for well over a decade, and I had a pretty good idea of what to expect from the development kit. If you're looking for the best possible way to get started, visit the official Crystalfontz website. This display is the Crystalfontz 1.54-inch 3-color e-paper display, and even though 3 colors might sound a little bit limiting, we can use a few artistic effects to simulate multiple shades from a distance. But just to get started, the development kit uses 3 subsystems: the e-paper display itself, a controller board such as an Arduino or the Arduino-compatible Seeeduino, and an adapter board to go between them. To get all 3 subsystems at once, you can simply purchase the development kit. This is something I recommend doing because the adapter requires 3.3 volts. 5-volt Arduinos such as the Arduino-Uno will damage the system, and the Seeeduino board has a switch that makes it easy to be certain that the adapter board is receiving both 3.3 volt power and signals. If you're confident that you already have a 3.3 volt Arduino available, then you can order just the e-paper display and the adapter board like I did. Just note that the source code that you'll use later is intended for Arduinos that use Atmega microcontrollers, meaning that if your Arduino is ARM-based, you need to make substantial changes to the source code in order for it to work. In addition to these 3 base items themselves, I'm using a USB cable, jumper wires, long-centered breakaway headers to make the jumper wires compatible, a soldering iron, lead-free solder, safety glasses, and as usual, an anti-static workstation. For software resources, you are going to need the Arduino Integrated Development Environment, also called the IDE, Microsoft Paint or a similar Bitmap editor, Crystalfontz free Arduino compatible code, and the Crystalfontz free Bitmap conversion tool. You can find the links for those last 2 in the description, and they are free to use. Before I actually unbox the display, let's go ahead, visit the official website, and then download the example code. The source code contains the wiring and pinout instructions, so it's best that we look at it early. Search for the display by part number, and when you find the link for the example code, simply download it, extract it, and then open the example sketch by double-clicking the .ini file. This should bring up the Arduino IDE. Right off the bat, we should see 3 relevant files: the main .ini file that we just opened, a header file that contains lookup tables, and a second header file that contains custom graphics. If we take a quick look at the main source file, you should encounter an area that shows the pinout for the Arduino. 2 wires, power and ground, already correspond to marked pins on the Arduino. The next 3 going upward are part of a serial peripheral interface, also called a SPI bus. The final 3 pins indicate data, commands, and hardware flow control. So in total, we're needing 8 jumper wires to go between the Arduino compatible board and the adapter board. When we unbox the package, we can see that these jumpers are already supplied, and we can briefly inspect the display. At first, it may look like the display has a demo sticker attached to it, but this is a true pixel level image. The e-paper display accepts 152 by 152 bitmap images, and the software that we just saw will use the SPI bus and the other wires to match that image to an array of thin-film transistors, also called TFTs. We can also see a ribbon cable on the display, which is where we need to attach the adapter board. The adapter board itself is more than just a simple breakout because it supplies the unique voltages required by the e-paper display. Before we attach them, some Crystalfontz displays require that we solder a small jumper on the e-paper adapter board before using it. If your jumper isn't configured correctly, the display might not work, so you'll need to check the official lookup table to figure out if you need to solder this or not. For this display, I do need to solder it, and after just a minute or 2 at the soldering station, it's ready to use. Now that you have the jumper in correct order, it's time to attach the ribbon cable from the display to the adapter board. First, lay the display and the adapter board down on the table. Make sure both of them are facing up, meaning that both the components layer of the adapter and the graphical area of the display are both visible. Next, you need to carefully unlatch the connector on the adapter board. Do this by raising the black latching tab up about 45 degrees, and don't force it to go any further. Now that it's unlocked, carefully insert the ribbon cable on the opposite end of the connector. Press the ribbon cable in until you feel some resistance, and then carefully lock the connector back in place. It should look a bit like this image, and don't be too surprised if you still see some exposed copper. And with that out of the way, we can go ahead and attach a USB cable to the controller board and the computer. This next step is only for if you're using the Seeeduino board. By default, Arduino IDE won't recognize this type of board, so we need to download support for it. We'll start by giving Arduino IDE the link to the official Seeeduino repository. You can find this link at any time on Seed's official website, and as of October 2020, I was able to use the address in the description, copy the address, and then navigate to File, Preferences, Settings. Look for a field that says Additional Boards Managers URLs, and then paste the hyperlink. Choose OK, and now that we've done that, we can go to Tools, Board, Boards Manager. On the resulting list, search for the board that best matches the board that you have, and then follow any on-screen prompts to get it installed. Depending on your system, you may need to restart the Arduino IDE momentarily, or unplug and replug the USB cable. And with that done, the Arduino IDE now supports the board. So this next instruction applies to everyone. We're going to upload the example program, so we now need to navigate to Tools, Boards. Select the board that you're using, and then navigate to Tools, Port. Select the appropriate COM port, and if you're not sure which one to use, now would be a good time to look at Windows Device Manager, or possibly unplug other USB devices that you don't need at the moment. Once you have the correct port selected, you should be able to press the upload button, and the Crystalfontz example code should compile and run without any problem. In other words, just be sure to double check your own settings. Now it's time to wire up the 8 jumper wires that we saw in the source code. Use the silkscreen layer on the Arduino board and the display adapter board, and you should have all 8 connected in no time. When you're done, it should look a bit like this. Notice that because I had female-to-female jumper wires, I had to use the long-centered breakaway headers to make the jumper wires work with the control board. If you have everything configured correctly, the example code should begin to generate its own images. As you can see, the refreshing process is quite a bit different from conventional LCDs, and the system will blink new images into the active screen in a process that takes a few seconds. Once the new image is set in, then you're free to power off the Arduino or even disconnect everything, and you'll still see the original image. This is why the technology is increasingly more popular in smart tags, and if we let the program play out, we can see even more patterns such as white, black, yellow, checkerboards, and a few partial screen updates. If it's your first run-through, I recommend having Arduino's serial monitor active and set to 9600 BPS just so we can verify things are working. There's a 20-second dwell time between test images, and we can easily adjust this by looking for the define wait time directive in the source code. For practical applications, Crystalfontz recommends waiting 2 minutes between refreshes, but for demonstration purposes, 20 seconds is good for now. Back in the source code, we can also disable individual screens by redefining them from 1 to 0. It's also worth noting that there's an option for attaching a microSD card or something similar. But for today, our next objective is to generate our own custom image and basically go from a picture on Microsoft Paint to a custom image on the display in as few steps as possible. Whatever you use, you want it to be a program that lets you do pixel level editing with the option to save as a 24-bit bitmap. For Microsoft Paint, this seems to be the default setting for Windows 10. Draw your image, and for the best accuracy, you'll want to use pure white, black, and yellow pixels according to the values you see here. If you try to use other shades of yellow, they may be converted into white pixels on the display as part of the conversion process. Now, luckily the converter program is still an ongoing project with Crystalfontz, so you should periodically check their GitHub page For the latest version, if you're looking for additional shades of yellow, there's also a graphical effect called dithering. If you're a fan of pixel art, then you're probably already used to seeing it, and from a distance it can be very effective. For now, I'm going with this example that I created, so it's time to save it. If you're given these options, then you want to set the format equal to 24 bits, set run length encoding or RLE to be disabled, and do not write color space information. If your file is in the correct format, then you should get a .bmp file of around 67.8 kilobytes. Again, this image also needs to be exactly 152 by 152 pixels, so if you need to scale something up or down, consider a different program because Microsoft Paint will introduce aliasing and other artifacts when it scales images. Now that we have a ready-to-use bitmap, it's time to return to the Crystalfontz website and then download the Crystalfontz bitmap converter. You can also simply search for the part number bmp-to-ePaper, and again, this is a free download. Download and scan the package, and after you unzip the package, you should have a single Windows executable called bmp-to-ePaper.exe. Run it, and after a possible Windows security prompt, you should see the following interface. Click Browse, and then navigate your file system until you find the bitmap image that you created. Select it, and you should see new options appear. For this black, white, and yellow variant, I've selected Convert to ePaper. I've set Inverted, RLE, and Two-Dimensional Array to be all unchecked. Black and white is set to 1 bit, red is set to NA or not applicable, and yellow is also set to 1 bit. After that, you can double check everything, and then hit the Convert button. After you acknowledge the change, you should see a new header file created in the exact same directory as your original graphic. This header file now contains unsigned arrays that correspond to the graphic. For this example, that means we have one array for the black and white channel, and an additional array for the yellow channel. Copy that new header file into your sketch directory, that is, the same directory that had the source INO file, and then add the custom header file to your project by navigating to Sketch, Add File. In my own example, my custom graphic was called custom6.bmp, so this header file was automatically named custom6.header. Before we can get this custom image on the display, go back to the original source file, and near the top of the file, type in #include custom6.h, bearing in mind that you should just replace custom6 with whatever your custom name is. Also, make sure the name is inside quotes, and then we want to scroll down until the very start of the loop function. This is the area where we want to turn on the display, and then use the image drawing function to transfer the two custom arrays to the actual ePaper display. So let's start by calling the function powerOn with no parameters. Second, we want to call the function called load_flash_image_to_display_RAM. This function takes 4 parameters. The first parameter is the horizontal number of pixels. Recall that's 152, but Crystalfontz has already defined this number under the name hrez. The second parameter is the vertical number of pixels, and in similar fashion, this is already defined as vrez. The third parameter is a pointer to the monochrome or black and white portion of the image. At this time, all custom header files will name this array mono_1bpp, and we can verify this if we want by looking at our own header file. Finally, the fourth parameter should be a pointer to the yellow portion of the image. By default, this is labeled yellow_1bpp, and with that, that's all we need to push the image to the display. Next, I'm going to use the serial print method just to give myself a custom text message for debugging purposes. So I'll just call this refreshing custom. Next, we want to hold until the display is ready for another image. This means that we need to pull the ePaper display ready signal, and we can do that by running the digital read command over and over again. Better yet, we can do that as part of a loop, so we'll simply say while digital read ePaper display ready is equal to 0, we just loop over and over again. After that, we'll throw another text string just so we can see if there's progress made. And finally, we power off the display and then wait for the default wait time of 20 seconds. Go ahead and double check the code, save everything, and then hit upload. And with any luck, your custom image should appear on the display. If we take another look at the custom header file, we can see that it's composed of 2 arrays at 2,888 bytes each. This is a lot of memory to consume on the Atmega 328P, which is what ran our code, so you should only expect to fit in around 3 custom images unless you get creative about optimizing the program or using some type of image compression. RLE is one of those methods, so it's worth considering. Also, like I mentioned, the current version of the bitmap converter tool seems to encode most shades of yellow as white pixels. This means that pixels that you thought were good might wind up looking a bit like this, unless you recolor them, but it's also easily avoided, and might not even be an issue for future releases. For larger e-paper displays and different color varieties, not to mention LCDs, be sure to visit the official Crystalfontz website or the contact page. To summarize, these electronic paper displays have properties that are quite different from what I'm used to, and yet the example codes and the development kit made it easy to get started with very little training. And after trying out different ideas for labels and tags, it's not hard to see why this technology is so popular. What the system lacks in refresh rate, it makes up for in low energy demand and daytime readability. The active surface has a semi-gloss appearance very similar to the pages of a magazine, and in terms of tech support, Crystalfontz Engineering was highly responsive like usual. So that's it for now, and if you found this useful, be sure to like and share the video. This helps me understand what people are interested in, and it helps the channel in general. Our monthly Patreon poll for October 2020 wants to know what type of power sources you use for your own projects. This includes batteries, energy harvesting, and other methods, including USB. Stay posted for more electronics, robotics, IoT, and communication systems, and as always, have a great day.